Hello, welcome to section 4.2. We're going to talk about nomenclature of alkanes, which means essentially um, how do we talk about alkanes, hydrocarbons, and is there a systematic way that we can go about naming them? So the reason why we need a systematic name is because in maybe 100 years ago or more, scientists discovered that this molecule was really good at helping prevent bacterial infections in hospitals. And just so happened that the molecule was called phenol. There wasn't really a great systematic reason for that. In fact, it could be called by several other common names depending on who was selling the chemical, and that all gets very confusing. So if you're trying to talk about molecules and you don't have a systematic way um, of looking at a molecular structure and communicating what that structure is to another scientist, then it could be that you don't understand what it is you're both trying to tell each other, even though you're talking about the same molecule. So the International Union of Pure and Applied Chemistry, or IUPAC, came up with these set of rules that really helped in distinguishing what atoms and molecules should be called. So to follow the set of rules, there are four steps to take. So first, number one, you identify a parent chain. So what that means is we're going to start with an example molecule. Here we go. Let's start with this molecule here. So a parent chain is what we call the longest continuous chain of carbons that runs through a molecule. And in this case, that starts there and goes to the other side. So that's 5 carbons long, right? 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5. Great. So we identified the parent chain and we know that it is 5 carbons long. Like we said in 4.1, the suffix for alkanes is ANE. So all we need now is to figure out how to communicate that it is 5 carbons long. And to communicate that, we need to go to the Greek prefixes for numbers. So this system of numbering is that if it's 1, we would say meth, 2, eth, 3, prop, 4, bute, 5, pent. Good. So we found pent. That is 5. If you want a larger amount of these prefixes, you should look at table 4.1. For this class, it will be important, I think, for you to know up to 10. So I'll go ahead and write up to 10 here for our uses, where 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. There we go. So then when we're naming, we would call this longest chain, we would call that pentane. I put the T in like this because you don't typically have the dash whenever you're naming a molecule. All right, so then number 2 in our list of things to do, ID, and well, I guess it's more like ID or identify any substituents. So the word substituent is a one that we use in organic chemistry, and it is the term for something bonded to something else. So in this case, substituents are going to be things that are bonded to the parent chain of carbons. So here we have 2 substituents, we have this one and this one. These are 1 carbon substituents, and if you remember, the abbreviation or the prefix for 1 carbon is meth. And every time we identify a substituent, we put on the suffix "-il". So each of these would have a name of a methyl. All right. The next step is to number the substituents, or give them an address, give them a home. Much like how each of our houses or apartments or wherever we're living has an address, so we must also give the substituents on a carbon chain an address. And if you notice, I marked down in our parent chain a certain numbering system from left to right, but also you could have a numbering system like this from right to left that has completely opposite numbering. And so you might be asking yourself, which one do we use? It seems pretty arbitrary. Well, the IUPAC people have given us some nice guidelines here too, because you want to use the numbering system that gives you the lowest score for each substituent, or the lowest overall value for all the substituents. So in this case, in purple, we would have 3,4-dimethyl as our substituents. And notice here what I've done. We have 2 substituents, so we need to say that both of them are present as a methyl. So 3, 4 tells us that. Then when you're doing a systematic naming, or when you're naming something systematically, you can't just put a number right next to a letter. You have to put a dash in between. So it's 3, 4 dash. And then because there are 2 methyl substituents that we're naming, we say di. And it's important here because you have to name all the substituents of the same type at the same time. So that's why we're saying dimethyl here. And so 2 is for di, 3 is for tri, 4 gives us tetra, 5 gives us penta. We kind of use a similar system to the one on the right. So that was the purple one. The green one, however, gives us a different numbering system, and it would be 2,3-dimethyl as our name. And so that is actually a lower score, so the 2,3-dimethyl is what we should use. So last, in our last step is to assemble the name. And we simply assemble our substituent name here with our parent name that was up here. So then we would have 2,3-dimethyl pentane. So that's kind of how you go about naming a molecule. We'll certainly do more examples of these in the future, but that is in general how to make a systematic name for molecules. It's really important to keep in mind that you have to identify the parent chain first, and it has to be the longest carbon chain that you identify as the parent chain. You can also have rings instead of just a linear type of molecule. So here, this would be a cyclopentane instead of a regular pentane. And we can even put substituents onto that cyclopentane. So this would be a 1-ethyl. Whoops. After numbering, this is 1, 2, 3, 4, 5. We would then have a 1-ethyl 2-methyl cyclopentane. And you notice here I gave the ethyl 1, and that's because you try and stay alphabetical if possible. So if you have ethyl and methyl together, then ethyl always comes first, and you want to try and number that first as well, if you can. If it doesn't matter, like in this case, that's what you want to try and do, because you theoretically you could also have said 1-methyl 2-ethyl, but that's not alphabetical. Or you could have said, sorry, 2-ethyl 1-methyl, but it's better to go with the ethyl there. Something to keep in mind, let's say that we had this molecule. Where now this is a, let's see, that's 1, 2, 3. That's a cyclopropane. Then in naming this, we would say this is 1-ethyl 2,3-dimethyl as our substituents here. And you notice that even though D looks like it should come before E, actually the di, tri, tetra, penta don't count in the alphabetical ordering of these names, so you leave that out. Okay, last thing is about complex substituents. So you can have, for instance, so we'll say it's complex substituents. And that's a case where you would have, perhaps, if we have this molecule, go like that. All right. Oh, and like this too. Okay, so we have to identify our parent chain. It looks like our parent chain is this. And we should number it somehow. Let's just start with this numbering system. 1, 2, 3, 4, 5, 6, 7. So that's 7 carbons. So that is a heptane. Okay. Now it says, or next we need to identify our substituents. So it looks like we have one substituent here. So you could name this in 2 different ways. You could either use a common name that IUPAC has allowed us to use, which would be, so we'll say the common name. Common is equal to isopropyl. Or you could use a systematic name for this complex substituent. And we would say the systematic name is sorry, use a thicker pen here. 1-methyl ethyl. I kind of prefer you to use 1-methyl ethyl here, but IUPAC rule says you can say you can use either, so it doesn't matter. And when you're naming, or when you're putting on, or when you're assembling the overall systematic name using a complex substituent, it's pretty straightforward, because here it looks like we already have our numbering correct, because if you number it the other way, it's also in the 4 position. So we would say this molecule is called 4,1-methyl ethyl heptane. Yes. All right, so last topic for 4.2, it's a kind of a long section, is the naming of bicyclics. So if we have a molecule that looks really funny, like this, this molecule actually has two different cyclic alkanes kind of like touching each other. If you could imagine that you have 2 cyclopentanes, and then you kind of like weld them together at these two carbons. That's sort of what we have here. And then they share this third one. This one they share. So a little bit about these bicyclic structures. Bicyclic nomenclature. Sorry for my handwriting again. In this bicyclic nomenclature, first you identify bridgehead carbons here, and these are the carbons that kind of bridge the two cyclic structures together. Then you start to count the carbons. So then we have 1, 2, 3, 4, 5, 6, 7 carbons. So we know this must be a heptane. And it is a bicycle, so we call this a bicycloheptane. But what makes it special in the nomenclature is this little bracket type thing that we have going on. And that is used to show you how, or like, it's used to show you the size of the rings that make up the two cyclic structures. So you just go from largest to smallest of the number of carbons that is on each section touching the bridgehead. So here there are 3, 2 that make up 2 carbons, and 1 that make up 1 carbon. So from largest to smallest, we would say 2, 2, 1. And we'll go over some more examples of those too. So this has been section 4.2.